Hello and welcome to the Albuquerque Public Library for more fun digital programming. My name is Debbie, and today we're going to explore hovercrafts and learn a little bit about using air pressure to move an object. We'll talk about Isaac Newton's first law of motion, his third law of motion, and we'll talk a little bit about friction. I'm going to show you how to make a very simple hovercraft using just a few items you have around the house. Let's go over the materials you're going to need to gather up. You're going to need a few old CDs, a bottle cap. This style works best, the kind that has a pop top. You're going to need a glue gun with plenty of glue sticks, some kind of cover or paper plate to protect your table. You're also going to want to gather up a balloon, maybe 9 to 12 inch in diameter, a clothespin, and maybe some push pins. And of course, markers to jazz up your hovercraft. Did you know that a hovercraft is actually a vehicle that floats on a cushion of air when it moves around? In order to hover, air is pushed downward onto a surface, creating this cushion. You can't actually see the cushion of air, and that's what makes the movement of a hovercraft so very special. So picture this. You have a craft sitting on the ground or on water. You turn on those air engines and the craft lifts just a little bit off the surface and hovers. This is known as the lifting force. The lift needed to produce this hover is determined by how much air is released, its mass, and how fast it comes out of the engines, the velocity. Together, this is known as the reaction force. In our experiment today, the air source is the balloon, not powerful engines, and the velocity is regulated by the opening in the bottle cap, not powerful fans. The action force of the air released from the balloon creates a reaction force lifting the hovercraft. And this is an example of Isaac Newton's third law of motion. So let's go over that. Isaac Newton's third law of motion says, for every action or force in nature, there is an equal and opposite reaction. I want to repeat that because it's important. For every action or force in nature, there is an equal and opposite reaction. Because of the interesting way hovercrafts move around, they can move on many different types of surfaces like land or water. A little later, we'll talk about what effects smoother surfaces have on movement. So let's get started assembling our hovercraft. Plug in that glue gun and use some kind of protection to keep your counter or your table safe. Remember, be sure you ask for an adult to help you when you're using glue guns. While your glue gun is heating up, you can jazz up your hovercraft by drawing on it with markers. You can make all kinds of designs. Once your glue gun is ready, I want you to apply a generous layer of glue to the bottle cap. Okay? While this is firming up, we're going to place it onto the opening of the CD. As you can see, let's let that glue dry, okay? For our experiment, you want to create a really good seal because you don't want any air leaks. Give the cap enough time for the glue to cool down and firm up. Once that's done, we can blow up your balloon. Let's do that. We're going to use a little handy dandy balloon pump. Few good twists, and use one of those paper clips to keep the air in. It's not a paper clip, it's a clothespin. Use the clothespin to keep the air in. And then you can very carefully fit it over the glued lid. You can release your clothespin and straighten out your balloon. Make it look nice. Get ready to release the air and watch your hovercraft move with air power. You can blow it up again and again and repeat the experiment. So let's review what's going on here. Air from the balloon passes through the lid and is forced downward onto the surface, creating a cushion of air that this homemade hovercraft floats on. The cushion of air reduces friction from the table. Who knows the definition of friction? Friction is the resistance of motion when one object moves relative to another object. Reducing friction makes it a lot easier to start objects moving. Newton's first law of motion says, an object will remain at rest or in motion in a straight line unless it's acted upon by an external force. Our homemade hovercraft was at rest until we opened the pop-top and allowed the air to escape. The escaping air lifted the CD ever so slightly, creating a cushion of air and reducing friction, and allowed the CD to move around. When it slowed down, I gave it a little push and the movement changed direction until the balloon totally ran out of air. That's Newton's first law of motion being demonstrated. Let's talk a little bit more about friction. We would expect that smoother surfaces allow for a uniform cushion of air to lift the craft, making it easier to move around, but we also know that while a rough surface still allows the air cushion to lift the craft, the air won't come out evenly, so we would still expect the craft to move, it's just not going to move as smoothly. For a complete study on friction, place your hovercraft on different kinds of surfaces, such as carpet or grass or asphalt. Observe how it moves. This is all we have time for today. We hope you had a good time. We sure had fun with you. We want to thank the All of Us research program, which supports citizen science and SciStarter. These programs help anyone, anywhere, engage in science exploration, including you. Check them out at scistarter.org. We appreciate their support of your public libraries. Remember to subscribe to the Albuquerque Public Library YouTube channel and come back and visit us for more fun digital programming. Bye-bye.
That was pretty cool.